In this problem, we have a crate sitting aboard a flat truck and with a coefficient of static friction between them equal to 0.75. And we want to know how the rate that the truck can decelerate without the crate smashing into the cabin. So the way I visualize this problem is that for the truck to be decelerating without the crate to move, the crate also has to decelerate at the same pace. So they will have equal acceleration. Now, for this to take place, I'll demonstrate this with the free body diagram. There has to be a force pointing in the direction of acceleration, providing this acceleration to the crate. And this is done with F. This is the net force, is equal to ma. Now, in our case, we're trying to find the maximum acceleration. So this is a maximum net force is equal to mass times the maximum acceleration. So what we have to do is determine what caused a force like this to take place. And in this question, the only possible thing is the force of static friction between the truck and the crate. And this does point in the correct direction. If the truck is decelerating and the box would want to move forward if it was frictionless, the force of static friction will point in the opposite direction and push back. So here, the net force will also be equal to the force of static friction. Force net is equal to force of static friction, which is equal to ma, but it's also equal to coefficient of static friction times the normal force. Now, the force of static friction is less than or equal to this, but we're talking about the maximum acceleration, maximum net force, so maximal force of static friction, and therefore it's equal to mu s Fn. So now we have to determine what the normal force is, and what that does is it opposes force against the wall, and here the wall is the floor, say, so there's a force pushing it down, and the normal force will oppose that equally. So the force of the normal force is pushing up, and this is opposing, should be obvious, force of gravity. And as the force of gravity is equal to mg, the normal force will also be equal to mg. Now what we have is we have a pretty good equation right here for our net force. So I'm going to write that down. Our maximal net force is equal to force of static friction. So it's equal to mu s Fn. It's also equal to the force accelerating the object, which is going to be ma. And now that we have our equation for a normal force, we can insert that. So say mu s mg is equal to ma. And then we can cancel out m on both sides. And I'm going to put a on the left as well, because that's what we're looking for. A, which is the maximal acceleration, is equal to the coefficient static friction times acceleration due to gravity. So our maximal, and we have these numbers. So our maximal acceleration is equal to 0.75. This is our coefficient of static friction times 9.8 meters per second squared. This is our acceleration due to gravity. And we can simply solve for A. Our maximal acceleration, or deceleration, if you will, is equal to 7.35 meters per second squared. So 7.35 meters per second squared is the maximal deceleration that the truck can undergo without the crate moving relative to the truck. I hope this was helpful. Thank you.